Okay, we're going to be looking at inverse functions, and we're going to take a look at these three different functions here. And though they look really similar, you'll see the numbers look almost identical throughout all of them. Each of them represent a different type of function. So the very first one you'll notice, technically you could say is kind of the power of 1. This is a linear function. Okay. The second one here is the x value, or the variables to the power of 2. I should have specified that with linear. The x values to the power of 1. This is a quadratic. And then this one here, the x is underneath the square root, so this is a root function, specifically a square root function, and there's technically an invisible little 2 here in terms of a square root. Okay, so we're going to go through all three of these, and you'll notice that all three are kind of written in a transformation form. We have a vertical stretch, usually referred to as an A. This is a horizontal stretch or compression, usually referred to as a K. There's an addition or subtraction attached to the x value, which is usually the C. Can't remember if it's the C or D. Really, doesn't matter what you call it. And then the vertical movement up or down of the function is the D. Now, I've applied all four of these to a linear, a quadratic, and to a root. And you'll notice when we're about to get into it, for linear, we can actually just simplify it. The quadratic, we can simplify it a little, and then from the root, we're going to have to do the entire inverse. So let's move over into the linear function here. So we have the inverse of the linear function, and here it is. Well, because this is all, technically power of 1, we can do a lot of distributive property to simplify this before we do anything with the inverse, okay? So this half here, we're going to multiply this half by both terms inside of that bracket, so we still have 4 times 1/2 x, or x over 2, however you want to write it. I'll write it as 1/2 times x, but you could always just write it as x over 2, plus 1/2 times 4 was the value of 2, okay? Again, this 4 is still multiplied before we do anything with the subtraction of 5, so we distribute that 4 value there. 1/2 times 4 is 2, so that's going to end up as 2x. 4 times 2 is going to be 8. And then we're going to subtract 5. So this linear function now reads 2x plus 3. So f at x can be simplified to this. Now, to find the inverse, I'm going to rewrite the f at x as a y value. And you're going to notice here, I'm going to write the x in red. What we're going to do is we're going to swap the x and y values to find an inverse, and then just isolate for y again. So we now have x is equal to 2y plus 3. So what are we going to get when we do the inverse of a linear function? Well, we'll bring that 3 over. We get x subtract 3. X positive 3 becomes negative on the other side. And we have times 2y. And to divide that 2, we can divide the entire side by 2, or each value by 2. And I'm going to do each of them by 2. Okay. So we divide everything here. This cancels out, equals a value of 1. So y is equal to x over 2 minus 3 over 2. I'm going to write it so it looks a little more like a linear function. We have y is equal to, I can common factor out 1/2. So it's 1/2 x. So think of that as your slope. Rise 1, run is 2. Rise of 1 and a run of 2. That sounded very odd the first time I said it. And then we have a y-intercept of negative 3 over 2, or 1.5. I like writing it as fractions, but just be aware that's the equivalent of 1.5. So you still end up with a linear function when you find the inverse of a linear function. Okay, so keep that one in mind. Okay, next we go to the quadratic. Here's our quadratic function. We can simplify the quadratic just a little here. What's neat about multiplication is there's a rule of associative property. So technically this is a half times this, but this is set to a set of brackets. And I'm not going to FOIL it out because that's not going to simplify, that's actually expanding. But due to associative property, this 4 is also multiplied by these 3 terms. And you can multiply in any order. So I'm actually going to multiply the 4 times the half and turn this into just one single value here. So 4 times a half gives me 2. So now I have 2x plus 4 to the power of 2 minus 5. This looks like the vertex form of a quadratic. I'm just going to write that in there. So we can kind of tell this is a vertex form. We have our vertical stretch or compression, we have our horizontal translation, and we have our vertical movement here. Now again, I'm going to set this equal to y, and we're going to swap our x and y values. So now it becomes x is equal to, because again we're trying to find the inverse, x is equal to 2, bracket y plus 4 squared minus 5. Okay, so think of like a reverse BEDMAS when we're finding the inverse here. We're going to bring negative 5 to the other side, so x plus 5 is equal to 2y plus 4 squared. Okay, I'm going to then divide both sides by 2. And when we do that again, I can isolate each one. I could write it as x over 2 plus 5 over 2. Okay, and these ones kind of cancel out. Or I could write it the way I did above, both terms over 2. They're both the exact same thing. We're left with, on the right side here, y plus 4 squared. Okay. The next step would be to eliminate this squared here, and to eliminate that, we take the square root of both sides. So I'm going to square root both sides. Now be aware, I can common factor out that, I'm going to write this as square root now. I can common factor out this 1/2, so it becomes 1/2 x. And 5 over 2 is the equivalent of 2.5, but I'm going to leave it as a fraction of 5 over 2. Okay. Over here, these cancel out. They become a power of 1, which doesn't really do anything, so we're set to equal to, on the right side, y plus 4. And then the very last step is to bring 4 over. So we go 1/2 x plus 5 over 2. And then outside of the root, we have subtract 4 is equal to y. And I'll write it with the y on the left side. So y is equal to the square root of, so here's kind of our formal writing of it, 1/2 x plus 5 over 2, and then minus 4. Now, let's say we wanted to do a transformation or graph this. It'll actually be very helpful if we common factor out the value of a half. Okay? And the reason we're going to do that is because it's going to show us what our horizontal stretch or compression is. So when I common factor out that half term there, oops, realize these were lines. That's supposed to be a square root. I apologize. We get 1/2, and then in the brackets, so a half divided by a half, cancel each other out, we have x. And 5 over 2 divided by a half is just our value of 5, so x plus 5. And then let's reduce this root, doesn't need to be that long. Subtract 4. So here's our root function with a horizontal compression or stretch of a half, horizontal movement of 5 to the left, and a vertical movement down 4. Okay, so your quadratic turns into a root function. And finally, the last one we have is a root function. What happens with it? Now, there's no simplifying here, so we strictly go into inverting. So y is equal to 4 square root. It's nicer when I write with the line, I think. 1/2. This becomes, oh, sorry, I'm inverting. This becomes x on this side, and we got to isolate for y. So this is x, this is y. I hope I did that right on the other one. I wasn't really paying attention there. Plus 4, and then minus 5. So very first step, bring negative 5 over. We get x plus 5 is equal to 4 square root. And again, I'm going one step at a time. Once you get good at this, you can probably do quite a few as you go through. So 1/2 y plus 4. Next step is we have multiplication by 4, so we're going to divide both sides by 4. That's going to cancel this one out, equivalent of a 1. I'm going to separate these two again, so we get x. Actually, you know what? I'm not going to. I'm going to leave it as is so that you can see the common factoring, how it's a little easier actually when it's written all over 4. On this side, we're left with the roots of 1/2 y plus 4. Okay. The next step is to get rid of the square root. Well, the opposite of the square root would be to take both sides to the power of 2. Okay? I kind of want to write it in blue here. I'm going to put this to the power of 2 and this to the power of 2. Okay? So when I do something like that, the root and the square disappear. They create a power of 1, which really doesn't do anything. So we have 1/2 y plus 4. And this is x plus 5 over 4 squared. Okay. Now we have this half here. To bring this half over, you can technically divide by half, or you can multiply by 2. Okay? When you multiply by 2, 2 times a half is 1, and that's the whole point. You're trying to create 1s here, because 1s, they don't really change anything. So 1/2 and multiplying by 2 eliminate each other. And then you're just left with y plus 4. Over here we have 2 times the bracket. I'm actually going to separate this one now because it's going to look like a fourth of x plus 5 over 4. which is 1.25, I think, squared. And then finally, we're going to move that positive 4 over, so we get 2 times 1/4 x plus 5 over 4 squared minus 4 is y. And I'll put the y on the left side, so we're left with 2, 1/2, or 1/4, I should say. And we could technically common factor out that 1/4, so it's also within the squared here. We have 1/4 x plus 5. All of that is squared minus 4. And we have a quadratic function. Now, remember I talked about simplifying in the last version. Because this quarter here is actually within the umbrella of the squared, we can't multiply these through. In the other version, the squared was only to the inside bracket, so I could multiply these two. So just keep that in mind when simplifying. This is technically the simplified version, and this is a quadratic. So your root function, when we do an inverse, actually becomes a quadratic. So can we show all of them here? I think we can. So inverse of a root becomes a quadratic, inverse of a quadratic becomes a root, and inverse of a linear is just a linear again, and these were the 3 functions we started with.